So this problem says, for the above quartic polynomial, f of x is equal to x to the power of 4 over 2 plus x cubed minus 11.25 x squared. Identify the interval on which f is concave down. So first of all, to find where an interval, or to find where a function is concave down, we're looking where the function creates like an upside down bowl. So for example, this region right here looks like an upside down bowl. This one is a right side up bowl, and here's another right side up bowl. So we're looking for this concave down region, but it's a little bit difficult to tell exactly where it changes from concave up to concave down. So the way we can do that numerically is by finding the second derivative and setting it equal to 0, and that will give us our points of inflection. So let's do that first. Let's find f prime of x first. And using the power rule, we get 4x to the power of 3 over 2 plus 3x squared minus 11.25 times 2 is, let me just make sure, is 22.5. So 22.5, and then x to the power of 1. So we can simplify this just a bit by making the 4 over 2 just go to 2. 2x cubed plus 3x squared minus 22.5x. So that's our first derivative, but to find our inflection points we need to take the second derivative. So taking the second derivative is taking the derivative again, using the power rule. So that makes 6x squared plus 6x to the power of 1 minus 22.5. Now let's set this equal to 0. And we need to solve this equation for x. We could try factoring it, but it looks a little bit difficult to factor. So let's use the quadratic formula. Is x is equal to negative b, so negative 6, plus or minus the square root of b squared, 6 squared minus 4 times a times c, all over 2 times a. So simplifying, it's negative 6 plus or minus the square root of 36. We have 4 times 6 times 22.5 is 540. Since there's two negatives, it would be plus 540 divided by 12. So 540 plus 36 is 576. Let's check and see if that is a perfect square. It is, it's 24. So that makes negative 6 plus or minus 24 over 12. Let's split this up into into our two options. So we have negative 6 plus 24 over 12 and negative 6 minus 24 over 12. So negative 6 plus 24 would be 18 over 12, and 18 divided by 12 18 divided by 12 is 1.5, and negative 24 minus, or sorry, negative 6 minus 24 is negative 30, so that would be negative 30 over 12, which is negative 2.5. So we know that we have two inflection points. One is at negative 2.5, approximately here, and one is at positive 1.5, approximately here. So notice that this looks in the region of, like, visually, where it changes to upside down or a concave down, or like an upside down bowl. So we can say our interval where the function is concave down would be from negative 2.5 to positive 1.5. So I hope this video was helpful for you. If it was, please subscribe to my channel and share with anyone who you think might find these videos useful. Thanks.